students are still joining. The first thing I will do is, can everyone, did everyone see a link posted in the chat? That is for office hours. I believe, I believe the final exam is on the 20th, right? Let me make sure. Yes, it's on the 20th at night, right? Can anyone tell me what room the final exam is in? Is it in the same room? So it is wherever CUNY first says it is. So if someone is already logged in, can you see? I can log in. All right, same room, and it's on the 20th, right? And I believe it was at night, 6:15 to 8:15. Good. So then, okay, so feel free to take, let me share the, so that's the office hours I have on Friday, Saturday, and Monday. There's quite a few slots available for tomorrow. So please take slots. Okay, writing okay means you're okay with other students joining in your slot. Please write okay as much as possible so that I don't have to explain the same question to multiple people at different times, and so we can, accommodate more students in fewer slots. So that was one. I posted the link to this document in the chat. If someone joined after I posted it, it's there now. People are still joining. There now again. Okay. I'll just post it once at the end of the call also. So that's the first announcement that I had. And then with regards to the material for the final, so everyone has access to the scribe notes. Before we go ahead, you see this 96 over here. So this is important. This 96 means there are errors. There are 96 errors, or at least errors and warnings. So when I'm grading your scribe assignments, I will simply see if your file, the first thing I will do is I will see if your file is contributing to an error. And if it is, you lose points straight away without me even trying to fix the error. So if you have these notes and if your lecture, so for example, whoever did this lecture on 8th April, so you are losing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 already, and the assignment is only for 15%. So who is this? Okay, are either of these two people here, Mohammad Hussain and Sophia Yao? Mohammad Hussain is here. Mohammad Hussain? Yeah.
Yes,
So
yes, Professor.
you see, you have many errors, right?
Yeah. Give me time to fix it almost today or tomorrow. I fix it all.
Yes, if you can fix it by the weekend also, that's good because again, the notes
Yeah,
are for other students to read and understand. If there are errors, that means you're making life difficult for the other students.
yeah, yes, I got it. I got it. I try to fix it in the weekend.
Yes.
No worries.
And so
Okay.
this is not just for him. There are also like, like whoever 0501, Sangyu Kang and Hao Huang. I presume you guys are here too. So whoever, right? Please take a look at these errors and try to fix them. Otherwise, you lose points. And it could be a silly error, like you may have missed just something small. So that brings us to, so now let's go to the main file. So I believe we had, so error correcting codes we had covered in the midterm. Hall's theorem we had covered, Solomon. Right, so our material for the final starts from this section 11 onwards, from 3 set onwards, right? So it's from, that's very weird. Yes, so it's from 11 till 23, right? So it's roughly half. So sections 11 through 23 are what are going to be covered on the final. So are there any questions about the content for the final? What topics are on the final? Is there any confusion? Any questions? Feel free to speak up. So the final will be like the midterm, 5 to 6 questions, maybe one more because this final is a 2-hour final. So you'll have perhaps 6 questions or so, and you'll have 2 hours to solve them. And I will again try to make it like I made the midterm, where I have some questions for masters and some extra questions for PhD, but maybe I won't, in which case, the exam will state that you have to either do all the questions, and then I'll just have a higher cutoff for masters and PhD students when I'm assigning grades. So it could be that the exam is the same for everyone, but the cutoff for masters and PhDs will be more, or it could be like the midterm where I have extra questions for the masters and even more extra questions for the PhD students. And obviously, things like calculators and all will only waste time. So you're only allowed a pen and nothing else. I will be, so the final will be more strict in that I know that some of you during the midterm use sources from outside, and I know who you are. So I will make sure that you're not allowed to use things like phone or laptop, obviously. So I'll ask you to put your phones in your bags and put your bags away from you, because I know in the midterm some of you accessed online. So please don't try to do, anything that may get you kicked off the course and blacklisted from the department. All right. The chances of it being useful are anyway pretty low. So I would say it's certainly not worth the risk. All right, so sections 11 till 23. If we just quickly go over the topics, we had 3 SAT, where we have, so if you remember, 3 SAT is NP complete. So any algorithm for it has to be exponential time. 2 SAT, on the other hand, is polynomial time solvable. So we had a n squared time randomized algorithm for 2 SAT, which the main tool in analyzing it was the drunkard's walk on 1D. But then for 3 SAT, the algorithm became exponential time, and we had explained Schoning's algorithm, right? So here was the Schoning's algorithm, success probability, and it was a exponential time algorithm. Then we had simple randomized algorithms for maxsat and maxcut. And then we talked about the Lovász local lemma. If you have many bad events, but they are not too interconnected, then there is a positive chance that none of them happen. That was Lovász local lemma. We also explained Kargar's algorithm for mincut. That was a randomized algorithm where you randomly contracted edges. And then we had applied Lovász local lemma to a bunch of problems, specifically to SAT formula that have bounded degree, meaning no variable appears in too many clauses, for which we use the Moser-Tardos algorithm to solve those SAT formulae in polynomial time, as opposed to, the exponential time required for general SAT formula. And then we also showed, I think I showed other applications also, coloring. I don't know if they're here. Let's see, did I not show a coloring application of Lovász local lemma? I'm fairly certain I showed a vertex coloring application for the Lovász local lemma. Yep, here. This is a vertex coloring application for the Lovász local lemma. Good. I guess it was in the section, that's why it wasn't showing up in the table of contents. And then we had explained what integer programs were and relaxing into linear programs, which then we had covered all the algorithms for set cover. The set cover problem was a generalization of the vertex cover problem, which can be phrased as an integer program, which in general are an NP complete to solve exactly. But we relax them to linear programs, and then we do rounding, right? And different types of rounding schemes give us approximation algorithms. So not exact, but approximation algorithms with different guarantees. Also, there is, linear. So you should know the definition of a linear program or see those word problems. So if you recall in the class, I had opened some random online link which had word problems in linear programs, and you had converted them to actual mathematical linear programs. So also, make sure you're able to do that, to convert a word problem into a linear program. And so we continued our algorithms for set cover. These were all randomized algorithms. Then we also looked at the greedy algorithm for set cover. And then we moved on to the branch of online algorithms, where we saw a bunch of toy problems like the pizza problem, the ski rental problem. And then we saw two main big problems. One was the paging problem, for which there are many. So generally in an online in a question on online algorithms, you'll be given what the model is, and you may be asked to show that a certain algorithm has a bad competitive ratio. So there are examples that were done in class where you show, how do you show that a given algorithm has a bad competitive ratio? Well, you show an instance on which its competitive ratio is very high, meaning the algorithm performs a lot of computation or has a high cost, whereas optimum for that input has low cost. And therefore that ratio, the competitive ratio, is high. So we saw a bunch of strategies for the paging problem that have a high competitive ratio. And then we proved that the move to front algorithm has a competitive ratio of at most 4. And then I guess this was the last question, where the last Tuesday's Tuesday's lecture, where we talked about the experts theorem, right? So there we had the two cases: if there is an always right expert, and then we had the general case for which the multiplicative weight updates was the algorithm. So that's a quick overview of the topics that will be covered on the final. And I didn't have any ideas to go into any more detail. So that's basically all I have to say. If you guys have questions, feel free to ask. Otherwise, feel free to, start preparing. If you haven't already started, you could leave the call if you don't have any more questions at this time. So all good? No questions? Okay, Going once? No, any questions? Going twice? All right, then see you guys either in the office hours or at the final. Right. Take care, good luck. Oh, last thing, please take those the evaluation surveys, the course evaluations, please. So I'm getting emails. You guys should also have received emails. So please take the course evaluation survey as soon as you can. I think the deadline for you is before the finals, if I'm not mistaken. So just take 5 minutes and take the course evaluation. This is the first time this course has been taught, so it would be good to see, what you guys think about the course. Okay.